In the previous video, we showed you how our spec does its magic with a gas tube lamp. Now it's time to show you how to process your astronomical spectra. The steps I'm going to show you here are the steps that you can do on the astronomical spectra that you captured. You can follow along on a second monitor as I go, or later you can use the checklist that's in the lab PDF. The PDF also has some important notes that apply to just Mac OS users. So Mac users, be sure to check out those notes before going through these steps. Okay, now let's look at the first image that you captured. Your first step is to make sure the image tab is selected here. Okay, now let's click on the Open button and select the first spectrum from wherever you've stored it on your computer. The name of the file will be whatever name it was given when the image was captured. On my machine, it's image1, so I'll click Open. When the file's opened, you'll see all this noise over here on the right. We'll just ignore that and clean it up in just a minute. But over here on the left is the spectrum of the star that you captured. Notice there are a couple differences between this spectrum and the gas tube spectrum we saw in the previous video. First, notice that it's not in color. That could be disappointing, but you see, astronomers usually capture spectra in black and white or mono rather than color because a mono camera is much more sensitive to the dim starlight we study. At this point, you might be wondering to yourself, what? How can we use a black and white image to study color spectra? And that's a really good question. Notice here that the grating splits the light into colors before it hits our CCD camera here. Once the light is spread out by color, we don't need the color anymore. Even if the camera image is black and white like this, we know that any light at this end originally was the red light that got diffracted, and any light at this end was blue, and so forth. So that's why we can use a more sensitive black and white camera for spectra. A second difference from the gas tube spectrum that we saw earlier is that the star spectrum is much shorter than the gas tube spectrum. The gas tube spectrum stretched out over most of the image, but here we can see our star spectrum is really short. The reason for that is that the sensor on the telescope camera is much bigger. It is many more pixels in width from left to right, so the spectrum takes up less of the width. This won't affect our ability to extract information from the spectrum, but it is kind of surprising the first time you see it. But because it's so small here on the screen, it would be nice to zoom in to actually examine the spectrum visually. So let's magnify it. To zoom, I click this magnifying glass here, and this window pops up. Let me widen the window a bit. And now I can click once on the star and use the mouse roller wheel to zoom in like this. Ah, there's the star. And the image is pretty round. If the telescope didn't track the sky well, or if the sky wasn't calm, this might really be an odd shape. Now I can hold my left mouse button down to pan over to the right. And there's the spectrum. It's a little different than the bright emission lines we saw on the gas tube spectrum in the previous video. Here we see a fairly strong continuous strip of data with some tiny gaps rather than the bright emission lines we saw on the gas tube. Can you see those gaps? There, and some more down there. These gaps are called absorption lines, and they're caused by the star itself absorbing certain wavelengths as light leaves the star. Whether we see emission or absorption lines in a spectrum depends on the physical characteristics, like relative temperatures and things, of what we're looking at. We won't get any deeper into this topic in the video, but you can read up on Kirchhoff's laws if you want to know more. You know, it always amazes me that these gaps were introduced on the star itself, maybe trillions of miles away and ages ago, but we can still study them here on Earth today and learn some facts about the star. Okay, now on to the next step. I'm going to park the zoom window over here. We'll come back to it in a minute. And one more reminder for our Mac users. Check out the PDF before you try these steps. Okay, let's go. So I'll come over to the image and click and drag the orange lines to surround the spectrum. Notice that I can click between the lines to move them at the same time, or I can click above and below to move one at a time. Over on the right, there's our intensity profile. This peak is from the star, right from here, and this hump is from the spectrum itself. Now, to make the graph easier to work with, we suggest you drag the vertical divider to the left, like this, making the graph area larger. See those dips in the profile graph? absorption features, they're the gaps we saw in the spectrum. Here in the Park zoom window, these 3 gaps here are the absorption features in the graph. You know, if all we had was this zoomed image, it would be really hard to accurately measure these features. But in the profile graph, they're really clear. Okay, we're done with the zoom window, so let's close it. So right now, the x-axis is in pixels. You may recall that when we looked at the gas tube spectra, the x-axis was in wavelength or angstroms. What's the difference? Well, for the gas tube spectra, before we made the video, we told RSpec enough so it could convert the x-axis from pixels to angstroms. But at this point, we haven't told RSpec anything about the equipment we're using on your star. So RSpec doesn't know enough to do anything but label that axis in pixels. In fact, one interesting thing, we can determine the width of your camera sensor by just looking at this number here. The camera used for this image was a little over 3,300 pixels across. That's about the same size as many cell phone cameras, for example. Okay, now we're ready to do the processing steps to extract data from this spectrum. They can be a bit hard to remember the first time you see them, so I wanted to remind you one last time that these steps are also listed in the SpecLab PDF. Also, in case when you're doing these steps for yourself, you get lost, you don't know how to get back on track, you can always just close and restart the software. Or in an extreme case, you can select Tools and then reset the software to its defaults. Okay, one other quick thing. Here's how you can move around in the graph area. Start by clicking once anywhere in the graph to make it active. That's important. Then, you can just use your mouse roller wheel to zoom in and out from the mouse cursor, like I'm doing here. Second, you can click and hold and pan left and right, up and down like this. Third, and this is the most important one, you can double click to reset and pan all the way out, removing the zoom. And finally, we can zoom to a region by holding down the Shift key and mouse button while we draw a mouse. Here, I'll zoom in on that peak there. Okay, now I'll double click to unzoom. So now that we've seen how to open your image, set the orange capture lines, looked at the gaps in the magnify window, and saw how to move around in the graph, you know, at this point I was all ready to actually do something with your data. But then I realized we've been in this video for almost 8 minutes. So I'll tell you what, let's end this video here and save the fun for the next video. Take a break if you need to, come back refreshed, and then we'll pick up from here.